Good morning, Kevin Johnson. Thank you so much for joining us today. Let's start off by sharing a little bit about who you are and how you came to be involved in aerospace.
Good morning, everyone. And first off, thank you for having me on. To give you an idea, when I started aerospace, the very earliest memory I can think of is involving with my father. At a very young age, he worked with us to help build things as silly as model rockets. And we're talking here nothing too crazy. It was just a cardboard tube, a very small motor, nothing fancy, but this was pre-Google days, everything of that nature. And so he did his research through a book, everything like that, all on his own, including developing a parachute, camera system, and everything like that. And it was always something that stuck out to me, especially since he's an individual who only had a GED at the time. And all this was self-enforced, self-driven drive, forgive the redundancy, to accomplish this. And it was something, like I said, stuck out. And when I was looking into college, where to go, first a love of math, as well as a love of space, kind of naturally combined into aerospace engineering, where I ended up getting a degree from Penn State University, Aerospace Engineering. Shortly afterwards, worked Boeing for about 10 years, maybe 11 years, various disciplines. In particular, Rotorcraft, though, but it was production, sustainment, as well as research and development. Never lost sight of what my personal goal was, which was to get involved in the space industry. So after about 10 years, I started looking for ways to get into the field. Worked briefly for Lockheed Martin. I went the wrong direction and started working on submarines. But that did lead me to an opportunity down here at the Kennedy Space Center, working for Jacobs Technology as a system engineer, supporting Artemis 2, 3, 4, 1, so forth, the various space programs out there. As well, recently, as of last night, I graduated with a second degree in engineering management from Arizona State University, and will be starting my PhD in the fall at University of Central Florida in aerospace engineering, focusing on space exploration.
That's fantastic. Congratulations on that. That's a
Thank you.
big achievement. So when you talk back, I really like the story about your dad, right? And it kind of makes me think that some of our earliest teachers are our parents, right? And what from that. So growing up with your dad and that idea that it wasn't necessarily an academic education, but rather that drive, how have you adopted that to your own, your own life and your own pursuits?
So what that's led me to do is anytime I come upon an emergent technology or something that's just, hey, that seems interesting, I will take the initiative just based upon what he did and go out and research the topic on my own. I remember when hypersonics was really kicking in. I know it's been around for quite a while, but as everyone knows, it's really picked up, at least this wave of it, in the past few years. I had some interest and some background in the technology, but what I did was, I don't know much about this, and I don't like that. So I went out. I either would watch various videos or take various courses in order to educate myself. Not just beginner level, but up to computational fluid dynamics, as well as various other system integration classes. Similar situation with CubeSats, similar situation with computational fluid dynamics, as well as some other topics, 3D printing, so forth and so forth. His drive to learn something that he didn't know through his own means, whether it's education, books, so forth, is kind of what inspired me to take a similar approach. I balance that a little bit with also the academic side, but I think it's important to have that weighted balance in both.
Yeah.
Right. I would say you're in a great example of what we tell our children, which is the very best place you can be is internally driven to learn on your own, right? Whether in any form. And I think that's one of the best things a young child can do also is find some passion and just run as fast in that direction as you can and see where it takes you. Maybe you pivot, maybe you don't, but I think that's really interesting. Also, I like the idea of informal and formal learning.
Thank you. And actually, taking off that, I remember a couple weeks ago now, maybe even a couple months, I was out there doing some judging for science fairs in the local area. I think it was ISEF or something similar. And what you're saying about the drive, what I saw some of the kids do at those science fairs from a high school level was absolutely incredible. I remember one student in particular developed his own 3D printed thrust vectoring control rocket. Now, the student himself, incredibly focused on the thrust vectoring, But what we focused on from the judging side was the fact that in order to get to that point, he researched how to modify his 3D printer to print out metal filament. He then built his own kiln in order to stabilize the filament, if you will, and then developed all kinds of computer simulations, all kinds of prognostics in order to actually do the rocket. We're looking there just like stunned because, I mean, I look back once again to that small model rocket that we put together at that age, and I'm like, this is incredible that the kids are able to do that with the technology they have available, as well as the information out there if they're driven by it.
That's right. The difference in you and I and that generation is the internet, and that almost all information is available at no cost. And if you have a little bit of resources and you got to drive to find the answers, there's no top end to what you can accomplish.
Right, because I think it can be either that, what they say, the blessing or the curse, right? So I think technology has in many ways made, I don't want to say just students, because I'm just as guilty, made us lazier to some extent. Like the answers are always right there. You don't have to think too hard to Google something. But at the same time, for those who already have that innate drive, is to keep using that theme, that changes the playing field a lot. So what I would ask about that is for parents who might be listening, or even for some students who think, okay, so I hear what you're saying. I might be interested in AI or something like that. Do I begin just reading everything I can get my hands on online? Do I take some courses? And if you were to kind of give some advice on that, how could the modern day student find that self-education, if we could call it that?
That's an excellent question. What I personally find, to me, helps out even today is stepping stones. So start with something like very straightforward. If you can find a mentor, definitely recommend that. That's been one of the greatest things about working in industry is I work with people who have been, for instance, right now, I just spoke to someone last week who's been in the space industry since the 1980s, as in 1980 itself. And talking to that individual, you learn all that entire history there. They're able to guide and provide like best practices, ideas similar to that. When it comes to actually getting yourself started, start with something that you like or something that's interesting to you. What I mean by that is I wanted to learn more about computer programming, and we're talking here more about utilizing dev kits and stuff like that. So I went out, found a package of software as well as an application that I could use it for that was interesting to me. And by doing that, I was able to learn about software hierarchy. I was able to learn about object-oriented information, parent-child relationships, so forth and so forth, that are fundamental to software programming. Now that my company is starting to look a little bit more into model-based system engineering, I'm finding the same terms, concepts, and approaches here, where if I just had the hardware side, I'd only be able to approach it from the hardware side. Since I went out there from the software.
So you're anticipating the change in potentially your the industry you're in, and that's going to give you a leg up, right?
That's the idea.
Go ahead.
I was going to say, for students these days, that's the exact same kind of idea. There's both a combination of learning what's out there today, but also trying to see what's coming down the road. I mean, things are changing so rapidly that you need to keep constantly engaged. Not in a bad way. It's kind of exciting.
No. And in fact, I tell them, I said, the job you very well may have in 10 or 15 years probably doesn't exist yet. You just need to stay current as you can be. Another advantage, I think, of talking to the deep domain subject matter experts that have done it for decades, they can tell you places where you can avoid the mistakes they made and make your own new mistakes, right? I always used to tell my fraternity when I was the advisor, I'd say, guys, try to make some new mistakes. Here's the ones we made, go out and make some new ones. So I feel like that's also good, that depth of knowledge. I see the SLS in the background and I see your Artemis shirt. So I think it's appropriate that we ask, tell us about what it's like working at Kennedy Space Center at such a vibrant time with this, this renaissance, with the retirement of the shuttle, Space Florida, NASA, all the companies have really, pivoted, and we've done a remarkable thing here with this new space economy. So what's it like at Kennedy Space Center these days?
It is definitely exciting. Now, I have only been there about a year and a half now, but what I talk to when I see everyone there is that they haven't seen growth like that in this area since probably the Apollo days. Anyone that's been in the Florida region since those days knows how reliant on the space industry the local economy is, especially Space Coast,
Right.
hence the name. So the fact that you're seeing such an upswing in traffic and everything like that, and I mean space traffic, but also physical traffic, people moving here, so forth and so forth, has been quite a boon for us out here. We actually had a presentation recently, I think for the National Florida Space Council, where the Coast Guard did a space presentation saying that now the amount of traffic that they're getting from SpaceX, from all the various launches, is the largest that they have ever seen, and they have to fundamentally alter their approach for the coast. Something I never thought of, but was a fascinating topic.
Yeah.
Oh, with the
Infrastructure,
with the delivery of vehicles and the recovery of
Yeah.
first stages, right?
Yeah, plus the entire safety corridor, the approach, the fact that it doesn't have a dedicated landing area until just a little bit beforehand. You're talking hundreds of miles and so forth and so forth. Fascinating stuff. But overall, that's the entire theme across the Space Coast as well as the Kennedy Space Center. Is it's such an exciting time because of all the activity, because of the major programs, and the fact that we're set to launch the next moon mission. We're not talking in the next 20 years, we're talking this year.
And what the general public may not know is you've got launch operations, you have rocket manufacturing, and you have satellite manufacturing all there together, and all the secondary industries that are required to make those sort of primary things happen. It really is a good time to be a techie.
Well, and I was thinking too, as you were talking about how, they've had to kind of revisit how they're sending them up or they're coming back, but also from an infrastructure aspect from the surrounding towns. Those are kind of older towns, very rural. So I'd imagine with this influx of people that are constantly now coming out again, they must have to almost rethink what the area looks like for the visitors as well.
I would agree with that. In fact, we bought a house out here, I think November last year in the Vieira region. And they're advertising that they're expecting the population in the town to grow double in the next 5 years or so, which obviously blessing and a curse for many reasons. But you also have a lot more facilities coming up. You have a lot more stuff to do in essence, and you have a lot more folks coming down that bring with them their families as well as their ideas, income, and so forth, which is only beneficial to the region.
Well, it had been an untapped area for a while. I mean, after this kind of the program died out in the 80s, but you're so close to Orlando. So it does make sense that that's going to expand and become something that would be a really viable community for this new emerging. Let's talk a little bit about UCF, just because I know that that's where you're headed next. And I just mentioned Orlando. So I understand you're going into aerospace engineering. How are you going to take some of the lessons that you've learned all throughout your life and apply them to what you want to do with your PhD? Like, why did you pick there? Why aerospace engineering in particular versus all the other options?
Sure. So the one nice thing is over the past 7 years, I've been working towards that second bachelor's that finally got my graduation with. But because of that bachelor's, it's forced me to learn how to manage my time in a way that I wasn't expecting. We're talking here a full job that sometimes did come with overtime, and sometimes significant overtime. Since starting my secondary bachelor's, I got a wife, several kids, home, so forth, so forth, and so forth. So the biggest thing for me from that degree has been learning the time management skills to balance work, family, and school. Did a fairly good job, ended up graduating magna cum laude, which that was a nice accomplishment and was probably very beneficial towards getting accepted into the UCF PhD program. Also had a lot of help from folks writing various letters of recommendation throughout the career, volunteer efforts at a local helicopter museum, teaching girls in 3rd grade about physics of flight. Some various mentors at Boeing as well as peers were able to provide it well enough that I got into the UCF program. To answer your question though on why, once again, that drive for the aerospace always was there. And this is going to sound silly, but I had in the college days decided that one of my main career goals when it came to a professional career goal was to be a lead for the mission to Mars, the human mission to Mars program. But I realized that wasn't going to be a 5-year plan. That wasn't a 10-year plan. It was more like a 20-year goal. Right now, I'm in year 12 of my career, and I'm in the process of working directly at the space industry. as well as starting my PhD in space exploration. So this is all kind of going relatively close to plan and aligning with it. As to why UCF, many reasons. One, it's within driving distance of the home, so that's always nice.
Mhm.
Always helpful.
Two, their PhD program is highly rated. And three, the professor I spoke to is actually from close enough to where I'm from in Pennsylvania. Also went to my original degree place, Penn State, for aerospace engineering, and was there for grad school while I was there for my undergrad. So there's a good chance that we crossed paths, which was always kind of nice.
You know, that's a lot of good synergy, right? Like when
Yeah.
all of those things come together, and I'm just really fascinated. That didn't sound silly at all. That sounded an awful lot like, you know, when you make those like vision boards and this is what I want to do. And then it comes true because you see it there in front of you every day. It sounds like you had a plan that you recognized was not going to happen overnight, but that was not daunting at all. And I love what you're saying about how you're able to learn from every step along the way, this time management that enabled you to continue. It's not about instant gratification. It's about a journey, and this journey that you're on, like, it's really exciting.
There are also a lot of successes that you're having along the way that aren't the end goal, but the intermediate steps are also, you know, a lot of folks would aspire to have what you already have, and you're just looking at it as incrementally moving toward your end game. Just quickly for our audience, are you from Western PA?
I am from Western PA. I should
All
have
right.
led with that. I apologize. I am
Yeah,
actually,
well, we have to ask, are you from Punxsutawney?
I am not from Punxsutawney. I am actually from a very small town northeast of Pittsburgh by about 45 minutes. It's called Manorville. It's a suburb of Fort. Yeah, I know. It's a suburb of Ford City, which itself is in Katanning, or near Katanning, I should say, which is in Armstrong County.
That's outstanding. I've never heard of any of those places except Pittsburgh. So, well, that's outstanding. Yeah, Western PA is known for big deer and lots of NFL quarterbacks, and of course Punxsutawney, PA. And now, of course, Kevin Johnson.
That's right.
I wouldn't go that far, but thank you.
Well, let's see. Now, right now, you're going to pursue your PhD. What's your plan if things go to plan? How long will it take you to earn your PhD?
That's a fun one. I'm estimating about 7 years.
That's a
That
slow
makes sense,
burn.
yeah, but that makes sense. You're working, you have
Mhm.
kids. I mean, the fact that you're even got the bandwidth to go, you know, like most of us are like at the end of, I got to shut down. That's me at like 6 o'clock. I'm done speaking to people.
Now, my game plan is typically work the job from 7:30 to about 4:30, depending on the day. Go pick up the kids from daycare, do the kid stuff, visit with what. Thankfully, we're actually cube mates now from the working from home, so we get to socialize quite often. Sometimes for good, sometimes for ill, especially when we're on those kinds of meetings that you know probably all too well. But have a dedicated time, kid, family, from about 4:30 to 7:30, 8 o'clock. Then it's focusing on study or additional work from 8 to X.
That's where that time management came in. I can
That's
see.
where that time
Got
management
it.
came in.
That's outstanding. That's outstanding. Is your wife also in the aerospace industry? I know you said she's working from home, but are your fields close enough where you interact in the work environment?
Not really. She is a resource analyst for Hartford Steam Boiler, so they handle boiler inspections, in particular insurance. Mostly she deals with pressure vessel systems, so she
Okay.
schedules all the inspectors to go out and see that. It's kind of funny because their company actually does have some work out at the Space Center with all the various pressure vessels out there, but she's mostly focused on the West Coast side.
Oh, outstanding. Well, let's talk just a little bit about how we met. And I met you because of the AIAA. We were both part of Congressional Visits Day, and that's actually how we met. I've enjoyed doing that for a while, and I believe that is this your first year being a part of Team Florida? And have you done it with Team Pennsylvania prior, or whatever state you were in?
This was my first year overall.
Okay, excellent. Well, that's how we met. Remind me, were you with Owen? Were you on Team Owen?
I was on Team. He is very organized, by the way.
He's done this since he was in middle school when we first started, and that's how I kind of came to know Kevin. We were at a school where my debate kids are like talking about all this space stuff. I had no idea, you know, what they were talking about, but I was like, oh, okay, well, I can help them to talk about it. So we've had Owen, gosh, he's graduating. He probably just graduated yesterday, I think, as a matter of fact. And they started working as early as 6th grade on some of these congressional visit things. So he's had
but
his feet
the
wet.
chance to be a leader is something
Right.
they have to earn,
That's true.
right? So he started out as a rookie. He's actually going to the University of Florida, and I believe he wants to major in theoretical physics. So he wants to study the universe, I believe. So, but
That's incredible.
And because we met there, right? And I don't know. I think we just sort of hit it off. We were batting around the idea of a CubeSat conference, and the next thing you know, we actually do have a CubeSat education conference at Kennedy Space Center in the fall. So I thank you because it was our conversation that immediately led to some real world action. So it's always nice to take an idea in your head and turn it into the real world.
Yeah, you should talk about that conference a little bit. I mean, I know that is something that, I mean, Kevin is really excited about it. I don't know about the other Kevin here with us today, but what do you think? What are you expecting from that? Who's your audience?
So our target audience are middle school to college age students, faculty members, and educators. And of course, the conference is set up for them to come at no cost. And my primary goal, and I've started reaching out to the university teams now, is for Floridian college kids in Florida that are building the CubeSats. They get the first, they're our first choice for presenters. So we want young people speaking to even younger people about how to get involved with high altitude balloons, thin sats, small sats. It's sort of a way to feed the STEM pipeline. And then we'll charge a little for vendors. And what I'm really hoping is to secure corporate sponsors to help kids from the Orlando area and the nearby areas get transportation to the conference every day. That's what I'm really looking for sponsors for.
And I was going to say, we recently had a NASA System Engineering conference out in Huntsville. And I took time right before one of the kickoff sessions to advertise the small sat conference. Figured I can ask, worst case they say no. I said, go for it. So stood up, gave the whole spiel about what it was. Ended up finding out that it was recorded and broadcast across NASA TV Live, so that was fun. Didn't know it at the time. But out of it, even before we left that day, I had multiple people come up to me at the table saying that they wanted to know more information about it.
That's fantastic.
That's great.
And
Yeah,
so you hit on something with the passion you showed that other folks share that must not be realized yet, especially on the Florida region.
So I've been to small sat several years, and I begged them. I said, we need a track for, you do really well with grad students, companies, NASA, DOD, and industry, right? Those are all well established, and companies are often running, and it's the new space stuff. But what about feeding that pipeline to get those engineers ready? We need to start
early
at the beginning of middle school, if not 5th grade, to help them, learn I call it the culture of being in a small team, collaborating, engineering. The technical stuff will come, right? But the CubeSat provides a great vehicle, I think, a medium, right, to help teach culture, communication, all that critical thinking. I love the constraints alone, right? Kids come up with great ideas, but I'm like, you're gonna put that into 300 cubic centimeters or something really tiny with 500 grams and 0.25 watts, right? How are you going to make that happen? So those are some of the things I enjoy. And I know in your world, engineering is always about constraints, right?
I was going to say trade-offs is engineering. That's the end of the day. But one of the things I found most interesting about the conference and folks coming up to me is one of the individuals, she came up to me, mentioned that she had worked for SpaceX for a bit and then took a job offer at JPL, was working there. And she said, love the job, but if I had to work a program where I wouldn't see results for 10 years, I don't know how that would help me from a learning, because you don't have that learn, fail, learn from, don't forget. It just takes so long to go through the process. But she said she had an opportunity to work on a bunch of CubeSat programs. And those have a 1 year, 2 year turn, and you're able to learn everything very quickly. And you have a bunch, how do I put it? you're able to take more risk on. And obviously not like human flight risk, that kind of stuff, but the cost of failure is much less. So you can do things to a different pedigree than you would on your James Webb Telescope kind of program.
Yes.
You're talking a different risk management approach, and that's definitely something in industry. Taking that back, that I also think of to what you were saying. As I mentioned, my dad launched a rocket just with his research online through a cardboard tube and everything like that. Imagine what kids today are able to do with these types of CubeSat technologies. You guys work with high schoolers that are putting satellites into space. At the end of the day, that's what's happening.
Right.
That's
right.
incredible.
And part of that is the better access to space. We are probably 10,000 times less expensive than the web, or maybe even a bigger factor of that magnitudes, right? And what's nice about us is if we can find a ride on an experimental, like a nascent rocket company that has to do some test flights before they can take customers, we're willing to take the risk that the rocket will blow up, right? Because as you know, all the education will happen before the rocket ever takes off. Getting that vehicle, the spacecraft, ready to get integrated into the rocket. That's I was always told that was 98% of the learning. I do believe that.
And I'm just thinking too, listening to what you're saying about the girl that you met with the long term. How do I see anything kind of come from that with CubeSats too? It's at least the 3 years from the time you guys go from proposal right to the getting it underway. So they kind of get a little taste of, I have to commit to something. I have to see it from start to finish. Not everybody does.
It's definitely not a video game,
right? So
yeah.
I've got to take it from start to finish. And by doing that earlier, I really, now I'm starting to realize that the benefit isn't just in that final product. It is that teamwork that you're saying along the way. It is that idea of the time management and the acceptance that my goal is a journey. It's not going to happen the minute
it's
start.
Perseverance too,
Yeah.
right?
It's really good.
You got to stick it out to the end.
And I was going to say, you get to enter very different phases of the program that way. You not only have your setup, your initial phase, your build, your design, your production, but you actually get into the corrective action troubleshooting phase, where you get to see where if you cut a corner, you're going to get burnt by it, and where decisions were made. What's the classic one? You have your known knowns, your known unknowns, and your unknown unknowns. You get to see where all those very quickly come into play, and how you adjust for them, how you adapt for them, and how you meet your mission happens live.
Right. The most terrifying at our level, the most terrifying thing is the vibe test. The vibe test is the most terrifying because we did shear off some solar panels one time, but you're right. Yeah, I totally agree with what you said.
Well, we are kind of to the end of the interview here, and I feel like, I've just really enjoyed speaking with you and hearing I've got some themes, right, that I want to really just hit upon at the end. And it has to do a lot with drive, mentorship, and that time management that I keep hearing coming up. And I always kind of end with an advice question, but I led with that earlier on because I really found it inspiring to hear about how you've had this long-term vision. So Kevin, I'm going to give the last question over to you if you have one of Kevin, because I feel like he already did my advice one. So I don't know how you want to take this.
Yeah. All right. So Kevin, if you could look in, as you like to look at trends and whatnot, if you were going to advise students about what the future of the aerospace industry would look like in, let's say, 5 to 10 years, and students that are in high school now that will be entering the workforce in 5 to 10 years, what are the themes and the technologies and the programs that they might keep an eye on?
That is an excellent question, and I could probably go another half hour on this one. But some of the biggest ones that hit up for me are the ideas of machine learning. So now you're doing generative design based on constraints out there, but we're talking thousands, if not millions of constraints, where an AI system is able to do the design, like the quick and dirty stuff, and then you have the human side doing the much more detailed in the weeds calculations. Also keeping an eye on the various launch technologies we have out there. As much as SpaceX has reduced the cost, it's still able to go down a lot further, and we're seeing some more enabling technologies in that domain. Think about it. Imagine if you could reduce the launch cost 10, 20, 100-fold again. What does that exactly bring out? The other big one I'm thinking of is in-space manufacturing.
Yes.
You hear that constantly coming up. And we're talking near term, 5-10 year stuff. And how do you enable that in particular? How do you get your raw materials in space? How do you manufacture in space? How do you rope in an asteroid to mine it? So forth, so forth, and so forth. I mean, why not?
Administrator Nelson was just at Redwire in Jacksonville, Florida last week on Tuesday. He was visiting a company who specializes in manufacturing in space. So I got AI, I got machine learning, manufacturing in space, launch technology advancements. I think we did the jets that carried a small rocket to a certain altitude, 50,000 feet. Balloons may very well be a good launch vehicle for rockets as well, because they can ascend very gently, and avoid, it's the thick atmosphere that's the hard part, right? Space is easy once you get there. So
I was going to say, and you've seen that centrifuge launcher that they keep
yes, I
talking
have,
about?
and they were going to put it in Hawaii, I believe, at one time. We visited the island on Hawaii. They were going to put it on the southeast corner of the Big Island. Fantastic technology.
Crazy G-forces. But when we talk about getting raw materials in space, that's
Yeah,
one of those, it just makes sense kind of things too.
I don't see us launching a lot of living things through that mechanism. I don't know how many G's that is, but there's too many zeros on the G load.
Probably all the G's.
Yes, all of them. Well, listen, Kevin, not only do you have an excellent first name, you are a really, I have appreciated getting to know you. I consider you a friend. And I think that when we collaborate, folks like us get together, we can do some really not only meaningful things, but enjoyable things. And I find it's always nice to be around what I call like-minded zealots, space enthusiasts. So we want to thank you for your time today. And we want to know, we will let you know that we'll probably invite you back sometime in the future to see how grad school is going. And
when you talk about the conference, I want to hear more about that as you guys
and learn more about what's going on at the Cape. So thank you for your time today.
Thank you too.